Thank you very much, Jan Vidar. Just going to take over the screen sharing and start the presentation. So it's recording right now? Yeah, sure. Okay. And are you there?
We are here.
Okay. So the Teams client crashed when I shared my screen, but okay. Let's try that again. Okay. Let me see. Sorry for that. Okay, let's try one more time. Now you can see my screen, right?
Perfect. Perfect.
Good, good. Okay. So today I'm going to talk to you about a new and exciting product that just recently got released in public preview, which is called Managed DevOps Pools. So I think this product is going to revolutionize how you deploy infrastructure and apps within Azure. So hopefully you will get on the same page or have any comments or anything about that. But today I'm going to showcase you a little bit about the product, take you through a little bit of demo on how to get started, and etc. So to start, as Jan Vidar said, my name is Haflidi Fridthjofsson. I have been a IT specialist since 2011. I work currently as a senior cloud solution architect at Supersteria, and I've been a Microsoft certified professional since 2014. I was really lucky last year to get awarded as a Microsoft MVP within security. And now this year, when I got renewed, I was also really privileged to get another category added to my MVP award, which is Azure within infrastructure as code. I'm one of the co-founder of the Microsoft Security User Group. If you haven't checked that out, I highly recommend that if you're interested in all topics around Microsoft security. Most of my day-to-day job goes around Azure infrastructure as code, and security. During my free time, I have a family and 2 kids, so I spend a lot of time with my family. But during the not so busy hours, I tend to deep dive into a lot of technology around Microsoft technology specifically. And when I get a bit of time out of that, which is not a lot, because there's so much thing happening in this in this area, I do tend to do a bit of gaming, primary first-person shooter like Call of Duty, etc. But that's only when I get a time extra. You can follow me on LinkedIn. You can read my blog at azureviking.com, and you can also check out all my modules and everything that I've developed and made available to you publicly on my GitHub profile. So, to start with a bit of background history. I hope most of you know what Azure DevOps build agents are. These are the agents that you need to set up in Azure DevOps when you want to use CI/CD pipelines to deploy infrastructure or code to your applications in Azure. So I'm going to go a little bit about on the background and the challenges that those agents have, what agents are possible to set up, and how they are, not how they are set up, but what the little bit of background and the challenges they have. So when you are going to set up a build agent in Azure DevOps, you have 3 options. You can choose between those options that you see on the screen right now, which is Azure Pipelines, a hosted pool, self-hosted agent pool, or virtual machine scale set. I'm going to talk a little bit about these 3 options. Azure Pipelines or hosted pools are managed entirely by Microsoft. These are the default pools that you use when you take a default template and you just put it in your Azure DevOps pipeline. These agents are hosted by Microsoft, as I said. They work quite fine. They work for a lot of infrastructure deployments or code deployments. They are really good in that term. However, when you are working with a complex infrastructure like Azure Landing Zones framework, if you're familiar with the corp archetypes or the other archetypes that you can find within Azure Landing Zone, you get into a bit of challenge if you are hosting a lot of your services within a private network. So as you can see on the screen now, this is a secure baseline for an up service environment. You can see you have there a hub and spoke setup with where you're having network resources inside your hub, and then you have your spoke, which is basically where you're hosting and injecting all your resources into a virtual network. On this picture, you see there is an up service environment which has some applications hosted. The up service environment is an isolated resource in Azure, which is mostly often a private resource, which is not available publicly for unless you do it with a web application gateway or Azure front door. So basically, inside these landing zones, which are often inside corp archetype within the Azure Landing Zone framework, you need to have your resources behind a private endpoint. So basically, you have a storage account that has a private endpoint, you have a SQL database, etc. So all those resources that support private endpoints need to be set up there with a private endpoint, and the public network is closed down. When it comes to the Azure Pipeline hosted pool, you're not able to communicate to those private networks with those hosted pools because they're on the public internet, and they are not able to be injected within your DevOps subnet, for example, as you can see on the picture there. So then people organizations tend to go to the other options that you can find in Azure DevOps, which are the self-hosted agent pool or the virtual machine scale sets. The self-hosted agent pools are, of course, managed by the customer. So it's not managed by Microsoft, it's managed by you or the service provider that is managing your environment. And they are often deployed on a virtual machine, which is an infrastructure as a service, or you can now deploy them into a container instance or container apps jobs with a Catascaler. So these two options that I mentioned now are relatively new. They're not that new, but have been around for some time, and they tend to be easier to deploy and easier to use if you're using a not heavy workload requirements. So basically, if you don't need a really heavy workload on your self-hosted agents, you can use container instances or container app jobs with Catascaler. They work just fine. Mostly, they work really well with Terraform deployment, for example, which doesn't require a heavy CPU or memory. And they can also be injected into your private network. So basically, you can use those agents to talk to your app service environment that you can see on the screen there. The other option is to use virtual machine scale sets. What I see in most of the corporations, the large enterprises that I worked with, they use virtual machine scale sets because they need the scalability. They probably need some virtual machines that have a higher SKU and need to be more powerful. They're also possible to talk to the private network. So basically, they can be injected into a virtual network or a subnet and talk to your private resources. But there are some challenges with those options. So basically, when you're using Azure pipelines or the hosted pool, you cannot install all the required software on those images. However, you can install them before you run your tasks. If you run some installations in the pipeline, so you need to specify all the software that you want to install before you run your task. You don't have any, or you don't have a lot of pre-installed software. Some of them come with a pre-installed software because it's and you can check out the what kind of software is installed on those images in the documentation. And as I said before, you have no easy way to communicate to your private network. And also that I mentioned before is that they have limited resources of CPUs, memory, and disk space. So you don't get any high-end VMs. You're not getting any workload efficient virtual machines when you're using the Azure pipeline hosted pool. When it comes to the self-hosted pool, they are more tough to manage. You need to upgrade them, you need to maintain them yourself, you need to apply security policies on them, you need to make sure they don't have any security vulnerabilities, you need to manage the images, you need to manage all the software that you need to install on images, etc. And you can also, of course, install it into those images afterwards inside the pipeline, like the Azure hosted pool. But they tend often to be very time consuming. And of course, depending on your backend infrastructure, you need to manage and upgrade your images. Either it's a virtual machine image or a container image. Of course, it's not that if you create a container image, you can just forget. You need to take that image down again, upgrade all the software installed on the image, and then redeploy it or upload it again into the container registry and make sure you maintain that image. For the virtual machine scale sets, there are some known performance issues. It has sometimes been known for a poor scalability because they tend to scale down to 0. Unless you actually define a running idle agent, which is also going to cost you when it's running. So basically, if it's idle, it's waiting for a pipeline to start, it's going to cost you. And there's also some lack of support for some platform architectures. This is the same that goes with the self-hosted data pools, because you also need to, even though that the virtual machines are not, you don't need to wait for the scalability there, but you always have the same image and everything used in the self-hosted virtual machine. However, on the containers, you can spin up a new container with a fresh image if you want. So Microsoft decided to develop a product which is called Managed DevOps Pools. This product is tend to resolve a lot of those challenges, and I'm going to tell you a little bit about the background, why it was developed, go a little bit over the overview, and of course, like I said before, show you how to get started with this. So there is an organization within Microsoft which is called One Engineering System. And in Microsoft, there are over 100,000 software engineers working there. In 2021, One Engineering System took an inventory of all the running Azure DevOps agents and estimated there were over 5,000 self-hosted pools with over 100,000 agents running there within the Microsoft for diverse software deployment teams, of course. The thing that they noticed and got the feedback from the teams that because the reason why they were running so many self-hosted pools and all those 100,000s of agents is because these software engineering teams needed more customized agents than just running the Azure pipeline hosted pool. As I mentioned before, we need some private networking, we need more powerful Azure virtual machines, we need scalability, etc. So basically, teams were managing their own CI/CD infrastructure. But like I said, they faced some complexities. They were really inefficient. They had a really bad support system because some of them had not been updated in quite a while. That introduced some security risks, and some of them had that bad support system that if a pipeline agent went down, it took a lot of time for them to spin up the VM again and fix the pipeline that was pending this agent. One engineering system saw a good solution for this, and they developed a internal tool which is called OneIS hosted pool. And this OneIS hosted pool, or one engineering system hosted pools, was a unified service to streamline all and take all these challenges in, streamline it, so all Microsoft's software engineers could use this as their self-hosted infrastructure, or basically use that as their running agents. The main goal was, of course, to increase the security, make it more simplified, have it more compliant and compliant with governance and policies, and etc. So all these self-hosted agents or hosted pools were intact with all the security requirements and all the workload requirements. And a lot of those benefits that they got out of this pool, out of this solution that they developed, was they were able to address the requirements of having a private network that you can communicate securely with your resources behind a private endpoint. You could come with you could inject your own or use your own custom images with a lot of pre-installed software to use in your application building. They were able to use a backup pools or multiple Azure regions. If one of the Azure region went down, they could use another Azure region to spin up an agent and then go on with their pipelines. And as you know, with the Azure pipeline hosted pool, you don't get a stateful agent. You cannot use the same agent in multiple jobs or multiple stages because it spin ups a new agent when you run multiple stages, for example. So they had the requirement to have a stateful agent, because same goes with the self-hosted VM. If you have a self-hosted VM, you always use the same agent. You don't get a fresh image. So it's a stateful agent. So basically, they could reuse the agent, save some files on the agent, go into the next stage or the next pipeline, use the files there, and then continue with their deployments. And they also wanted to have the possibility to have more powerful Azure SKUs. So they were able to choose a selection of Azure compute families that were also tailored to their workload needs. In addition to that, they were able to use something that's called standby agents, because in Managed DevOps Pool, you can scale down to 0, of course, as well. And in virtual machine scale set, you can also scale down to 0. So you don't pay for the resource when it's running. So they introduced also a standby agent, which gets the pipeline, to run more, to basically spin up the agent and run faster, instead of waiting for the hosted pool to spin up, or the virtual machine scale set to spin up the agent, get it ready for the Azure DevOps, and then run the pipeline. So they had standby agents as well. Of course, when you're having a standby agent, you pay for the standby agent because it's standby and it's running. And after a success of this product that Microsoft has been using for the several years now, they decided to develop this for the external customer. So basically for the external users in Azure. So not as an internal tool, but for the customers to use. Then they developed the Managed DevOps Pools. So basically, Managed DevOps Pools is created within Dev Center and projects in your own tenant. This is a product that is entirely hosted by Microsoft. You can see the managed pools inside your Dev Center and your projects, but the VMs and all the underlying infrastructure is hosted within the Microsoft Azure subscription. So basically managed by Microsoft. The key benefits that I find really interesting in this is that this agent can be injected into your own private network. So basically, you're able to inject those Managed DevOps Pools inside your subnet and let them talk to your private network, which I find very good because I often tend to work a lot with Terraform. And in Terraform, you have state files, which are hosted on a storage account mostly. And those storage accounts need to be protected by not allowing public endpoints to them because state files include a lot of sensitive information. So you want to protect those state files. So then you want to disable the public endpoints, and then you cannot use the Azure Pipeline hosted pool, of course. So you need to use some of the other options. And that product here is an alternative to those two other options that are available in Azure DevOps. They're also available. They're also scalable, and you can also schedule them. So you can basically schedule when you want your agents to be standby. If you have a lot of workloads or a lot of workloads that need to be deployed between 9 to 3, you can have standby agents and exactly in between that time period. Then you can scale them down to 0 after this time period. You can also choose any Azure or basically any Azure SKU depending on your hardware requirements. If you need powerful agents, you can choose a powerful Azure SKU, so as long as you have a quota for that. Or you can use a much lower spec agent if you are just running a Terraform code, for example, because they tend to not need a powerful agent. The other thing that I find really interesting is that you can use a well-known image. So you can use the same images that the Azure Pipelines hosted pool uses. And those images are maintained and created by Microsoft, and they are also supported there. You can also pick a standard image from the marketplace. Most images there are standard server or a Linux machine. And I also find it really interesting that this is really cost efficient. So basically, you pay only for what you use. So basically, when the VM is running, you pay for that, and then it's taken down, unallocated, and put back into the pool. So basically, you don't pay for that running VM every time, all the way. But if you have some standby agents, of course, you're paying for them because they are running agents and they are just waiting for a pipeline to pick up. So how do we deploy this? We can deploy Managed DevOps Pools with a lot of well-known ways. So basically, the mandatory is you need, of course, a Azure DevOps organization. You, of course, need an Azure subscription. And you need to enable a service provider on your Azure subscription, which is called DevOps Infrastructure Pools, if I remember it correctly. I can show you a little bit later on in the demo. Optionally, you can, if you want to inject it into your private network, because you can set up this Managed DevOps Pools without your private network, which is then an isolated virtual network within the Microsoft Azure subscription, which has public access to the internet, and of course then they function as the same as the Azure Pipelines hosted pool, but you're able to have much more powerful agents if you want. So it's not a mandatory to inject it into private network. It's an optional way of doing it if you want them to be able to talk to your private resources. So of course, if you want to inject them into a private network, you need to have a virtual network, and then you need to have one or multiple subnets that are delegated to the Microsoft DevOps Infrastructure Pools for each pool that you want to deploy. So you cannot reuse the same subnet for multiple pools. You only use one subnet per pool, basically, yeah. Then if you want to have some custom images, you need to have your custom images inside your Azure Compute Galleries if you want to use them as well. This can be deployed by infrastructure as code through already released Azure verified module for Terraform. which is included in the link there in the presentation, which I will be sharing later on. The Azure Verified modules for Bicep are on their way. There are a few steps on the testing there, but they will be released in the coming weeks. Of course, you can deploy this natively within Bicep, so it's already available within Bicep. And of course, use ARM templates if you want, but I don't recommend no one using ARM templates today now, because you have Bicep and Terraform. It's good to understand ARM templates, but if you're going to build ARM templates from the scratch, I would advise you otherwise to get familiar with Bicep or Terraform instead. It's not yet supported with Azure RM Provider, because Azure RM Provider tends to go towards stable releases. So because this is in public preview, and they, at least not for now, don't support it. But it can be deployed with the AZ API provider. So that's how the Azure Verified module, Terraform module, is based on. It's based on the AZ API provider. And of course, you can go through the portal. But now I'm going to showcase you a little bit of demo. I'm going to do a stunt live, because I have prepared an environment if something goes wrong. But I'm going to deploy this with infrastructure as code and show you how it can easily be deployed with infrastructure as code using the Azure Verified module, Terraform module. I'm also going to show you how it works with private network. So in the same infrastructure as code template, I'm going to deploy a storage account, federated workload identity within Azure DevOps. I'm going to deploy basically everything, project inside Azure DevOps, everything that you need, and then of course the Managed DevOps Pools, etc. So let me change to the demo. You can still see my screen, right? Yeah, hopefully. So basically, I'm going to go into the virtual Visual Studio Code, and I'm going to show you a little bit of the. I have a folder here called Private Networking Live. I have another one deployed already, which is ready if something goes wrong. But I have some source files that I'm going to deploy into Azure DevOps within a repository to just showcase you how the Managed DevOps Pools agent is possible to talk to the storage account within a private network. So this is the template that I'm going to use. It's a lot of lines. Unfortunately, I need to use personal access token for my own deployment. And I will be sharing the TFVARS, or I will be sharing the description on how the TFVARS file needs to be built. To just need to put on few information, and then you can just run this template on your own tenant if you want and test this out. This is going to activate the or do the resource provider registration if you don't have it already registered, and then it's going to deploy everything into Azure DevOps, create federated credentials, create managed identity, and create all the resources that is needed. So to do a demo here, we start running Terraform init, and I'm using a Azure ARM backend in my own tenant. So now this has been initialized. I'm going to use Terraform plan. Just going to take out the plan. And while this is deploying, it takes a few minutes to deploy. I can show you a little bit around in the portal as well. Just show you how this is set up and show you the options in the portal. So basically, we have the plan here. We're going to set up a lot of resources, basically, 47 to be exact. And I'm just going to run this. I'm not just going to bore you with showing you the plan. But if you're familiar with Terraform, you can see the plan, and you can see all the resources that are going to be deployed. So we just hit apply and cross our fingers and see if this works. So I'm going to go into Azure portal. Let's just make this a bit larger, and we just go into just take out this filter here. And I'm just going to show you the existing resources that I've already deployed, so I can show you how Managed DevOps Pools are set up. So basically, the first you find the Managed DevOps Pools here in your portal, which is called Managed DevOps Pools. Oh, sorry, Managed DevOps Pools. Here's it. And I have one of them or two of them set up within the regions that are currently supported. Unfortunately, this is not supported at the moment in Norway, but it's supported in West Europe and North Europe at the time. It's similar to where Dev Center or DevBox is supported. I know it's on its way into Sweden Central, but I don't have the timeline on when it will be available there. But it's available in West Europe and North Europe at the moment, or other regions, of course. When you create a Managed DevOps Pools, you get a lot of information here. You can put in regions, etc., what kind of agent size you want to use, change the sizes. It's showing me the available SKUs for East US at the moment, because East US is chosen by default, and you can see you have a lot. But this is not showing you that you have actually a quota for this SKU. So if you don't have a quota, you need to go into quotas. You need to request a quota for the Azure SKU you want to use with Managed DevOps Pools. So basically, we have here a new option. You choose Managed DevOps Pools, and then you can see all the regions where this of the SKUs. So basically, I'm just going to show you UK South now, because I'm going to deploy into that region. And you can see I've already used 2 of my vCPUs out of 5 that I have default available. There are few SKUs that come with a default quota of 5. That means that you can deploy at least 2 parallel agents or pools agents into the pool. So you get actually two agents that you can run parallel. This is also based on the self-hosted licensing in Azure DevOps. So you need to have self-hosted parallel licenses, etc., of course, available. So this is based on that licensing model. There are a lot of them with 0s here, but there are a few with 5, and we have a list on the documentation side which SKUs will be default. Which will be default with queues to use, but then you can request adjustment on your queue quotas, not queues, quotas for your other SKUs that you want to use. And it depends on if the availability is small, then you of course will get some. You need to hassle a little bit with support, but otherwise most of them or some of them go automatically through. But this is really important to have available when you're using a different family of VMs or vCPUs. It's otherwise your Managed DevOps Pool will fail within the deployment. So if you go back to resource groups, and we just go back to found the right South, and we just see live here. These are the resources that are being deployed at the moment and are already deployed. So this didn't take a lot of time to deploy all this. So basically what I deployed is I deployed a managed identity to use with federated credentials to authenticate to this subscription from Azure DevOps. So I'm available. So I'm able to showcase you the whole run. I also deployed a dev center, a project, Managed DevOps Pools, a NAT gateway to your subnet, because that's going to be the default way in some time when they don't, because the subnet is no longer allowing public access by default. You need to enable it, of course. So then I deployed a subnet for the Managed DevOps Pools, which is delegated subnet. And then I deployed the subnet for the private endpoints. In my deployment as well, I deployed a storage account for the state files and a private endpoint to that storage account. And you can see this storage account is no longer not accessible through the public network. It's disabled, and it has a private endpoint connected to it, to the storage account. So other than that, we just need to go into Azure DevOps, as I've deployed this all by code, so I don't need to do it. I don't need to do anything manually. I need to do one thing manually, so just allow the pipeline to use the service connection, but we can't do that when we run the pipeline. So now I've just deployed the Managed DevOps Pools without any standby agents or schedules or anything. So it's just scaled down to 0. So it's going to take a few minutes for it to scale up to 1 and be available in Azure DevOps. So I just go into the project that I have here. We can show you the repository that was created with some Terraform sample code, where I will be creating a resource group within the same subscription, but it's using a state file on a storage account, which is in a private network. And it uses the Managed DevOps Pools as well. So just going to run the pipeline, see how that goes. So I need to refresh this because I know I need to give it permissions to use the service connection. It was created with the code as well. So now the pipeline will start asking for an agent from the Managed DevOps Pools that I just created. And we can see also the pool. Just going to show you the Managed pool. It was it's created. So basically, it's. Oh, I lost it right now. See. Yeah, here it is. So basically, it has another icon here. It doesn't have the same icon as most of the self-hosted agents or self-hosted pools, as this is on a self-hosted pool. But then you have the Azure Pipelines, which has this cloud icon here, and you have the same cloud icon here for the Managed DevOps Pools. Now I can see it's not running yet, but I can also show you a little bit what's happening in the portal. If I go to this resource group and into the management plane of the Managed DevOps Pools, you can also see there are a lot of metrics here as well. You see how many agents are available, or you have parallel. So basically, this depends on how you set up your pool with maximum agents. So basically, this has a hand-in-hand connection to your SKU. So if your SKU has 2 vCPUs, you're using the two vCPUs of the quota you get, and then if you add this to 2, it will be 2 times, and etc. and going on. You can also define multiple images here. I'm now using just the Azure pipeline Ubuntu 22.04, but you can also add other images like Windows Server 2022 from Azure Pipelines, or 2019, or Ubuntu 20.04. You can also select few images from the marketplace. You have the Visual Studio 2022 Enterprise on the Windows 11, where you can choose some Ubuntu servers and etc. I don't have any custom images in my compute gallery at the moment, so I cannot show you that. But you can also use your custom images. When it comes to scaling, you can this is the stateless or the stateful agent that I talked about earlier. You can get a fresh agent every time, so basically stateless agent, or you can use the same agent in multiple builds. You can define the maximum time for the agent to live. So basically, if you're not using it, if you just need to have it available for 1 day, and then it can be scrapped, and then you can reuse. You can build another one. You have possible to maximum 7 days here. Then you can define it from a few hours to 7 days. And the same goes with the grace period. You can also manually schedule your how many standby agents you want to have. You can have a pre-provisioning quick starters as well. You can have machines available from 9 to 5, and how many agents you want to provision. So basically, you have start time from Monday 9 to 5 every week, and then it will be provisioned a 1 standby agent at 9 on Monday, and after 5 on Monday it will be provisioned down to 0 as well to save you some bucks. So this it's really good to plan this out if you know how your workloads are and how you're going to use those agents. You can also automatically scale this, and you can also use and then there is some calculations, and you can have it like balanced, or you can have more cost efficient. So basically, there are fewer standby agents available or none. And this is calculated on your usage. So you need to use it a little bit, and then it can be calculated even further. Or you can have standby agents off, so you don't need to pay for the agents running. And then, of course, you need to wait a bit when the pipeline needs to request an agent, spin it up, make it available to, and make it available to Azure DevOps. You can monitor the agents here. We can see that it's already pending return, which means that the pipeline that I run earlier has already been run. And you can see this is the agent machine that was spun up. You see what image it's currently on, what image version it's using, and then it's allocated pending return or other statuses. You can also see this in the metrics. So you can see it took about 1 minute and 33 seconds to get spun up, and then a few more seconds to be available in a few more seconds to be available in Azure DevOps. So basically, the preparing time for the agent to be spun up was about 1 minute and 33 seconds. There's no error count at the moment, no failure stages, and pool provisioning health is it's not showing any metrics. You can see metrics as well from 1 hour, 1 day, 7 days, and 30 days. And now I can show you the pipeline and see if that has run successfully. So basically, the pipeline has run successfully. We can see it was going to create a resource group within the same subscription, and it ran successfully. So basically, plan and apply went through. I can also show you that this agent talked to the storage account that we have in the state file without me personally being able to look at the inside of the container, because it's behind the private endpoint. I don't have a line of sight in the networking on this. So, and if we also can also show you a little bit more to just make it more interesting, if I enable it to be accessible for virtual networks, I can show you the. Of course, need to wait a bit more time. Yeah, so basically the Terraform state file is here. This is the state file that was used in the pipeline. So back to make it private again. So yeah, so this concludes basically the demo. hopefully you've seen what it can do and how it's injected into a private network, and how to showcase you that it actually works with quite well within a private network. So to conclude, Managed DevOps Pools has recently been released in public preview. There is still no timeline for when it will be generally available, but hopefully it will be available GA in the end of the year. It's a highly scalable, customizable, and cost-efficient and really powerful product to use with Azure DevOps, and it's a really good alternative to all the three options that you have in Azure DevOps. That I find most interesting is that it can be used inside your private network, and that basically solves a lot of issues that most of my customers are having with that. They have state files on a storage accounts which needs to be private. So this will be a really good addition to and useful for those scenarios as well. The infrastructure and the agents hosted there are managed and maintained and supported entirely by Microsoft on Microsoft's Azure subscription. And also the possibility to basically come up with use the Azure pipeline images that are standard images that we often tend to hopefully we want to use, and or bring our own custom images into this when we have more requirement for prerequisites of software installment, etc. with for application building. So now I have some reference links in the presentation as well. I referenced the Azure Verified module that I used in the demo. I also will be sharing the demo content, and so you can use this and try it out. There is a link to my blog post there on that goes a little bit deeper into the first look of the Managed DevOps Pools, basically most of the content that I've showed you today. And then I have some links to the official documentation and the official blog post from Microsoft. Are there any questions?
I think it was mainly comments in the chat.
Yeah.
There was one question, but I think you answered it regarding outbound access from the VNet from the agent.
Yeah.
That was a question from Deepesh.
Okay.
Yeah, because you talked about when the changing the outbound connections will automatically not be available for agents. You have to have a
NAT gateway.
A NAT gateway. Yeah.
These are changes that are coming, but it's not made default yet.
Yeah.
You've probably heard a lot about virtual machines basically being will not defaultly have public IP. It's known information about there, but it's not yet default. So
yeah. Are there any other questions?
Feel free to come.
Chat, raise your hand.
Yeah. If there are no more questions or any questions at all, I can read a little bit the chat there, if then try to comment or answer it. Otherwise, feel free to contact me, and if you have any questions later. And I would really want to thank you for listening in, and thank you very much for having me here on the Azure User Group Norway. It has been a really, really great privilege to present this product to you, and a product that I find really, really interesting. So thank you very much, and have a great day.
Thank you, Haflidi. Have a nice day.
Thank you. Bye-bye.